Welcome to our demonstration on series and parallel circuits. A simple series circuit is set up as shown below. Here we have a 68 ohm and an 82 ohm resistor in series. The voltage of the battery will be measured and the total resistance of this circuit will be calculated. Then, using Ohm's law, the current of the circuit will be predicted and then measured. Because this is a series circuit, the total resistance is calculated using R total is equal to the sum of each of the two resistors in series. Therefore, the total resistance of this circuit should be 68 plus 82 or 150 ohms. The potential difference of the battery is measured by connecting a multimeter in parallel with the battery as shown. Let's watch a simple demonstration of this. To measure potential difference, we connect the multimeter in parallel with the battery. First, switching from milliamps to DC volts, then simply connecting the terminals of the battery to the multimeter, and we get a potential difference of 5.92 volts. So we can use that potential of 5.92 volts, and since in Ohm's law V is equal to IR, I, the current, can be calculated by taking the voltage and dividing by the resistance. 5.92 divided by 150 gives us a theoretical current of 0.0395 or 39.5 milliamps. Let's see how that's done. A 68 ohm resistor in series with an 82 ohm resistor. Electrons leave the battery, go through the switch, then through the 68 ohm resistor, then through the black cable, through the 82 ohm resistor. They then are connected to the multimeter. The multimeter is set to measure in milliamps. The electrons then go back through the battery, completing the circuit. We throw the switch and we get a measurement of 38.0 milliamps. The predicted current is 39.5 milliamps, and this is verified closely by our measurement of 38.0 milliamps. The slightly lower than predicted measurement can be accounted for by resistance in the connecting wires, possibly 5 ohms, adding slightly to the total resistance of the circuit and therefore reducing the overall current. Our next circuit is a parallel circuit, which is set up as shown below. You can see that the 68 ohm and the 82 ohm resistors are in parallel with each other. We use the same battery, 5.92 volts. The total resistance is calculated using Kirchhoff's law. Then, using Ohm's law, the current of the circuit is predicted and measured. Because this is a parallel circuit, the total resistance is calculated using 1 over R total is equal to 1 over R1 plus 1 over R2. In this case, 1 over R total is 1 over 68 plus 1 over 82. The total resistance turns out to be approximately 37.2 ohms. Using the measured voltage 5.92 divided by the calculated 37.2 ohms, we get a predicted current of 159 milliamps. We connect the circuit and measure the actual current. Here's what we find. Here's a circuit with a 68 ohm resistor in parallel with an 82 ohm resistor. Electrons leave the battery, first go through the switch. At the switch there are two separate leads. One lead, the black one, goes to an 82 ohm resistor. The red lead on a separate line goes through the 68 ohm resistor. These two leads are then connected at the multimeter, and the current is measured in milliamps by the multimeter. Electrons then go back to the battery. We throw the switch, and we find that the total current is approximately 141 milliamps. The slightly low measurement of 141 milliamps can be accounted for again by resistance in the connecting wires, approximately 5 ohms, adding slightly to the total resistance and therefore decreasing the total current. Finally, we will set up a series parallel circuit as shown below. A 68 ohm resistor is in series with two resistors which are in parallel with each other, a 68 and an 82 ohm resistor. We're using the same battery of 5.92 volts. The total resistance is calculated, and then using Ohm's law, the current is predicted and measured. Because this is a combination circuit, the total resistance is calculated using R total is equal to the first resistor, R1, in series with R2 and R3, which are in parallel with each other and in series with R1. Therefore, the total resistance works out to be 68 plus 37.2, or approximately 105 ohms. Using Ohm's law to calculate for current, current is 5.92 divided by 105, or 56.3 milliamps. We set up the circuit and measure the actual current. Here's what we find. The 68 ohm resistor in parallel with an 82 ohm resistor, both in series with a 68 ohm resistor. Electrons leave the battery. They then go through the 68 ohm resistor. After this, they go through the switch. At the switch, you can see there is a split. One goes through an 82 ohm resistor, the other goes through a 68 ohm resistor. These reconnect at the multimeter, which measures in milliamps, then back to the battery. We throw the switch and find that we have a current of 54.9 milliamps. Our predicted value of 56.3 is very close to our measured value of 54.9 milliamps. The difference can be accounted for by resistance in the connecting wires, adding slightly to the total resistance, therefore decreasing the total current. At this point, you should review a number of problems and applications requiring Kirchhoff's and Ohm's laws to find the solution.